Okay, we need to look at electrical conduction and how it is affected by temperature. As you know, we have three blocks here. As we go from left to right, you know that the temperature increases. And you know by looking at the particles, what's happening on a microscopic basis is that as we go from left to right, the average random kinetic energy of the particles increases. So as the temperature rises, so does the average random kinetic energy of the particles. In other words, they vibrate more. Now, let's take a cool metal where the particles are not vibrating very much. We've got a potential difference from the top left, which is negative 50 to positive 50. That gives us a positive potential difference of 100 volts. Now let's say that the potential difference is 100 volts and the current is, let's say, 5 amps. Now it's easy for the electrons to move because they're not impeded, and we can show graphically what this looks like. So they move very quickly because the particles are not moving, they don't impede the motion of the electrons. So given that we have a potential difference of 100 volts and a current of 5 amps, we can say that the resistance is 100 divided by 5, which is 20 ohms. So a cool metal will, in this case, has a resistance of 20 ohms. So it's easy for the electrons to move because they're not impeded. Second thing is that the resistance depends on the mobility of the charge carriers, and since these charge carriers have a great deal of mobility, it means that it has a low resistance. So a low temperature means a low resistance. On the other hand, if we have a hot object, a warmer object, the particles are vibrating much more. They've got a much higher random kinetic energy. As these electrons try to move across, they collide with these rapidly moving particles, and that impedes their movement, so the mobility is reduced. So the electrons are much more likely to collide with the metal ions in the lattice. It means that they're going to transfer some of their kinetic energy to the metal ions. So the metal ions are going to heat up, they're going to speed up and heat up. And it means that the electrons, the charge carriers, are going to have a lower kinetic energy because they've surrendered some of their kinetic energy to the metal ions. So there we have it. So the metal is going to heat up. So in this case, a high temperature is going to be a high resistance. So if we do look at it mathematically, we could say the potential difference is 100 volts as it was before. But this time, the current is 4 amps. It's a little bit lower. So 100 divided by 4 gives a resistance of 25 ohms. Now, how does that compare to what we had before? So before we had a resistance of 20 ohms when the particles were not moving very much. And in this case, we have 25 ohms. So by having a hotter metal, it means that the resistance is going to be greater because you're reducing the mobility of the electrons.